Hey, we have here today a pretty interesting looking integral from the MIT Integration Bee 2012. This was problem number 11. Okay, so we have this big ugly expression with a huge denominator with 3 different square roots in it, and it definitely can look pretty intimidating at first. But rather than getting overwhelmed by this whole thing, a couple things to notice. We have this, if we just focus on this first square root to the left, now this of course isn't so bad. If we just look at that as the whole integral, the integral of this is actually just arcsine. And the nice thing is we do have arcsine in this thing here and here. So this is making me think I can do a u substitution. Let's just try it and see how it goes. I'm going to make my u equal to arcsine of x. And then if I take my derivative from here, our du value is going to be basically that. It's going to be 1 over square root of 1 minus x squared dx. So I'm just going to make this substitution and see how it works out. So again, we have our full, this is going to be our du right here. So I'm going to just write this as a du in the numerator. This is going to turn into 1 minus u squared. And then this is the scariest part of all right here, right? This is going to be 1 minus our cosine. We're going to have a u in here, and then this piece is squared. Now I think that cleaned this up quite a bit, but we still have some issues going on. Now from here, it'd be interesting if I could do something with this arc cosine. Now what if I made this, we'll do another substitution. Let's do another substitution, and we'll call our t equal to this arc cosine of u. The thing about arc cosine is it's got a really similar derivative to arc sine. So we'll take our derivative. The derivative of arc cosine is actually just the derivative of arc sine times minus 1. So I can write this as minus 1 minus u squared du. Well, again, that's pretty much what we have right here. All I need to do is multiply this by a minus 1 to make it identically that. So we'll just multiply by a minus 1 here, and I'll multiply by a minus 1 out front so that I don't change the problem. And then I'll go ahead and make my substitution. So here this is going to give me a dt in the numerator. And then this piece here is just going to be turned into 1 minus t squared. But then from here, I think I'm just going to take this minus sign and just bring it in here to make this clear. So a lot of times for this, we'll integrate this to arcsine or do a trig substitution. But in this case, just notice this here is exactly what we have right here. This is exactly what we have except for in t. So the integral of this is actually just going to be arc cosine. So we can write this solution of this integral as arc cosine of t. And then from there, we're just going to need to back substitute with our t and u in order to finish this off. And of course, one thing I should mention is because we did 2 substitutions, you could have consolidated this into 1 substitution. I just think maybe it would be hard to see how this was all going to work initially. So for this back substitution, if I plug in arc cosine of u in here for t, we're going to write this as arc cosine of u. And now we just need to plug in our u value here, which is arc sine. So for our final solution, we're going to have arc cosine, another arc cosine of arc sine x, need the right number of parentheses, plus c, and that's it. Okay, so pretty nice problem. I always like it when you can have a really difficult looking integral and then you can solve it really easily with like 2 steps. So yes, I think this one was probably a lot easier than it looked initially. So I'll stop it there. Thanks everyone for watching. Have a great day.